Hi, I'm Dirk Dusharme. Welcome to Technorazzi. Continuing our series inspired by you, our viewers, we're going to touch on visioning systems. We've returned to CPM Labs in Rancho Cordova, California, where Craig Howell will give us the basics on visioning systems. Okay, Craig, last week you demonstrated for us a Starrett optical comparator, and this week looks like we're looking at what, its smaller, younger cousin?
This is a visioning system. It's put together by JH Technologies in San Jose. It comprises of a stage made by Semprex, lens made by Navitar, got a little CCD camera by Hitachi, a quadra-check display, and a screen to look at the results.
So one of the main differences is on the optical comparator, that was more of a projection technique of projecting a profile up onto a screen. This actually uses a video camera and a monitor.
This uses a video camera. This has superior front lighting capabilities. You can see the detail much clearer on this than you could in an optical comparator. You still have the same measurement techniques, but now you can zoom. This has a zoom lens where much of the optical comparators are fixed focal length.
And you can do much of the same functions?
Yes. So they'll do circle, distance, angle. You can use skew.
Okay. Well, give us an example of how you use this machine.
Okay, I have this set up on a dime, and we're focused on the president's nose at this point. I was going to suggest we take a reading of the radius of his nose.
All right, let's do it.
I'm going to zoom quite a ways in so we can really get a good idea of the curvature. There's some crosshairs on the screen, so I'll tell it we're taking a circle. We'll take a point, another point.
Now this doesn't have any kind of automatic edge detection like the optical comparator did.
This one does not. They do make them with optical edge detection, but this system does not. So here we showed the diameter would be 41.5 thousandths, so the radius of the president's nose is 20 thousandths and about 7/10.
Pointy nose.
Pointy nose. I have a little circuit here, which this will be good for.
See, when you're changing the lighting?
Changing the lighting, it seems to work a little better for this part. Sometimes they'll have call-outs of the spacing between the leads. So in this case, I'm just going to, actually what I'll do is I'll do a point, and if I tell the point, and I take two entries, one on one side and one on the other side, it's going to give us halfway in the middle. So that's our first point. Now I'll move down to this leg and do the same thing. Take a point, enter, go to the second leg, second side of it, enter, finish. So now I have 2 points showing on the screen. I tell it I want to do a distance, and I select those 2 points, and it tells me the distance between them is 05145, 51 thousandths, 4/10, 50 millionths.
So that was interesting. I've never seen that before. So you're saying the first thing you did was you took 2 points on either side of this lead so that it could identify where the center was?
It did. What I did is I made a point,
okay,
but I made the point from 2 different features.
Gotcha, okay. And then you did the same thing down here, and then it gave you the distance from in between this lead, from the center of this lead to the center of this lead.
Each point was the center of one lead.
Gotcha.
Then I told it, take a distance between the two.
Now what's the accuracy and resolution of this particular type of?
That's dependent on the quadra-check and the readers. In this case, again, this one resolves to 50 millionths of an inch.
Okay.
These have a little different specification. It's one of those where it's usually designated in metric. It'll be plus or minus 2 or 3 microns, and then so much for each inch of movement.
Oh, gotcha, right.
One of those formulas I love. You can use it on larger parts also.
It looks like to me that pretty much the main difference, aside from the video aspect of it, the main difference between this system and the Starrett optical comparator is this is really set up to do much smaller parts.
You're right. It's for smaller parts. It's also much more modular. We have some different lighting. We have some lighting from the edge. We have some coming down through the center of the lens. You can have lighting from below. It's much more modular. A lot of these components would fit on the comparator, but This is more versatile. You can set it up to do a certain type of measurement and quickly change over, just even in lighting, to do a whole different type of measurement. Here we can use the skew function again. As you can see on the screen, my edge of my part is not perfectly in alignment.
Right.
There's a little bit of difference. So to do skew, again, we would touch one edge, go skew and take a point, move to the opposite edge, move over till we're just, I'm touching with the edge of the crosshairs, you might notice. I'm not going to the center, I go to the edge. We're now skewed, so now any point we took in between, in the middle, will give us an accurate readout of where we're at.
Okay.
That wouldn't happen if you didn't have skew. You would have to guess where you would be.
Okay.
Let's do angle, the angle of this feature. We'll start out with the straight leg. We'll do angle, take 2 points on one leg of it. Now we'll take 2 points on the other leg of it. And it comes up with the angle of 132 degrees. 132.054, or you can change it to read degrees, minutes, and seconds.
So again, that's the angle between this edge and this edge.
Yes, it is. The angle between the two, this direction.
Right, gotcha. Okay. Well, thank you for showing us this piece of equipment today, Craig.
You're welcome.
Hi, I'm Dirk Dusharme, and welcome to Technorazzi. Continuing our series inspired by you, our viewers, we're answering questions related to stuff. Hi, I'm Dirk Dusharme. We're going to touch on visioning systems. We've returned to CPM Labs in Rancho Cordova, California, where President Craig Howell will give us the basic things. Continuing our series inspired by you, our viewers.
Do it again because it looked like you were almost about to sneeze.
Yeah.
That was perfect.